Hello everyone, hello classmates. Welcome to this video that I made for fun. And actually, I was thinking about this for as long as natapos yung klase natin kanina. Iniisip ko talaga na gawin ko to kasi para man lang malay nyo makatulong sa LT2, and I really enjoy this part of the number theory, which is modular arithmetic, and it's kind of motivating to do this, especially with the group with this set of people na I think is quite new to modular arithmetic. So this gives me, I think, an opportunity to lay down my perspectives, kasi there is a lot of ways to solve a modular arithmetic problem, and it's not just one, and you can do it more elegantly, I think, which we'll witness in a bit. And okay, so I want to start by saying na saan na ba tayo on modulo at this point? And what I mean by that is, paano na ba dapat natin tinitingnan itong modular arithmetic as a sequence? Okay, so suppose we have three different sequences or three different sets. Sabihin na lang natin, yung una is the first 13 positive integers. The second one is the first 13 multiples of 3. And the third one is the first 13 powers of 5, starting from 5 to the 1. Okay, so it's not so interesting to list them that way. But if we consider finding the residues modulo 7, this is what happens. We form a cycle. Okay, again, so if you get each of the residues modulo 7, we can find a way to make the sequence periodic or cycle. Cycle meaning we had a first term 1, okay, and we can make it go back to 1 again. But also, if you multiply this same sequence, di ba? Kung papansinin mo itong second set natin, multiples of 3, this is just the first set with each element multiplied by 3. And you get a different way or a different ordering in which you still get from 3 to 3. Diba? Kasi 1, 2, 3, 4, 5, 6, 0. And next is 3, 6, 2, 5, 1, 4, 0. So nagra-rumble yung ordering. And it is based on how, on what we multiply the numbers. Either 1, 2, 3, 4, 5. Kasi dun din magbabase yung residues eh. But the sizes remain the same. So the size of each of the periods of this of these two sets is 7. Kasi 'di ba yung distance nung bumalik siya sa 1 is pang 8th term na siya eh. Ganun din sa second set. So size 7 yung period. And pagdating sa powers, since powers have a different story, how we handle their congruences is that for this case of 5, for example, powers of 5 to the k where k runs from 1, then it will go back to 5 again as a residue when k is equals to 7. Okay, k equals 1, 5 to the 1, the residue is 5, and the residue 5 to the 7 is 5 also. And I think you get why is this true. And it's because of Fermat's little theorem, wherein 5 to the 6 should be 1 mod 7. And it shows here in the sequence. But aside from that, again, yung pinaka-essence of why am I introducing modular arithmetic in this way is for you to realize na you're not just only taking remainders, but as you can see, the residues can repeat and the pattern can repeat as well, depending on how you manage to set up this sequence in the first place. And so much for that. So let's pwede na tayong bumalik sa dati. So let's start first at linear congruences, which I think will be one of the first items in the LT. The following are nice to use when confronted with a linear congruence. Actually, it's not far from an equation. It's just, dahil meron nga lang tayong modulo M, balikan natin, we subject these congruences to finding the residues. Pwede natin gawin yung ganoong way na yun. Pwede nga nating pakialaman lang yung isang side eh. Pero depende yun. So, ayan. So, pwede tayo mag-add or subtract both sides ng congruence. Pwede tayo mag-times. And the converse of the second one is not always true. It's only the case when M and C are relatively prime. So you need to make sure that C and M is prime when you want the converse of this. So okay, paulit-ulit lang ako. Anyway, so let's apply that. For our first item, sige, yung linear congruence ha, I'm just copying everything. So ito. So the usual way na sinosolve natin siya is hinahanap natin yung inverse ng 17. And I can't fault it kasi kapag hinanap natin yung yung inverse ng 17 modulo 21, tapos na tayo eh. 'Di ba? Sige, gawin natin 'yun. So 17x congruent to 21. Sorry. 14 mod 21. Ang inverse ng 17 mod 21 is 4. Ay, hindi. 5 pala. 5. Sorry. Kasi 17 times 5, 85. So, that's, ayan. And we can multiply both sides by 5 by that second theorem kanina. 5 times 14 mod 21. And so, 85. So, we end up with x congruent to 70 mod 21. X congruent to 7. And okay, we got it. But halimbawang ayaw mong computein gamit ng inverse. So this is one alternative approach we can make. So starting from 17x, we can make 17 smaller eh. And by I mean smaller, smaller to either 1 or negative 1 na matatapos yung congruence natin. And how would I do that? So I can subtract the left side by 21x. We're okay doing that since it's a multiple of 21 anyway. So this becomes negative 4x congruent to 14 mod 21. And now, so paano ako makakarating sa x? Gusto ko x, di ba? Ang coefficient ng x's na ito is 1. Yan yung gusto kong marating. But how would I do that? Ano muna ang parang peripheral vision na kailangan natin gawin? For the lack of a better term, so I can multiply this by 5 so that this becomes 20x. So 20x congruent to 70. And then again, since meron na akong 20 and I know negative 20 plus 21 is 1, I can just add back 21. And take note, I am just pinapakialaman ko lang yung left side. Mukha lang siyang mahaba, pero if you think about this approach, mas madali siya eh. I mean, in the sense that it's a systematic approach. You do not need to determine the inverse. You just need to subtract and add multiples of 21 for x. Or if mas convenient sa'yo, pwede kang mag-add sa right side ng 21. Kunyari, right side, diba? Right side mo, 14. O plus 21. You won't add plus 21x though. Kasi, constant yun eh. So, hindi mo pahihirapan yung sarili mo. But ayun, again, way 2 is more systematic. And 1f. Ayan. So, mahirap hanapin yung inverse niyan. Okay? I mean, you can do that, but bakit mo gagawin yun? 'Di ba? So, how would we do this the easier way? So, instead of subtracting on the left side or adding, kasi it would just make x more complicated. So I'm not using the inverse here ha, I'm using the systematic way na ginawa natin. So I would try to subtract this by 2401 and see what we can do. So it becomes negative 2397 mod 2301. 2401. Okay. So yan, mas madali na. And you know that this negative number is divisible by 3. It's because 2 plus 3 plus 9 plus 7 equals to 21. Yeah, 21 is divisible by 3. And okay, by familiarity, okay, we can say that we can simplify this to 3x. We just divide both sides by 3 kasi ayan, hanggang hindi siya divisible by 9 eh. So, negative 799. Kasi if it were divisible by 9, edi sana dinivide ko na lang diretso, di ba? Ayan. So, negative 799 modulo 2401. And what next? I can add back. Okay? I can add back 2401. And this would be congruent to ano ba? Wait lang ha. Hindi ko din alam eh. Magka-calculator lang ako. 1602. So 1602 mod 21. 2401 pala. And hooray! 1 plus 6 plus 2 equals 9. This is divisible by 3. And so, 1602 divided by 3 would be 534. Okay, see what we do this entire process. Kanina, ang pinakialaman natin is yung left side. Kasi gusto natin makarating sa x. But then, on this second problem, we realize na pwede din naman pala nating pakialaman yung right side. We can add constants, we can subtract constants. The reason, again, is because napakalaki ng 2401 just to add, or I think parang pahihirapan pa natin yung sarili natin kung left side yung pakikialaman natin. Yun lang. And this is how you typically solve a linear congruence if you don't want the inverse. Okay? If you don't want the inverse, ayaw mong nang huhula, gusto mo na ma-witness mo siya systematically. And aside from linear congruences, we also have divisibility tests. Alam ko di na-discuss nito, sir. Feel ko kasi parang simple lang eh. I mean, if you think about it, simple lang siyang, parang yun yung mga typical na divisibility tests na, yung kumakalat sa school kapag mga math month, yung mga techniques, calculation techniques. And kasama dun yung pag-determine kung determine it, this number is divisible by 8, divisible by 9, 10, 11, and so forth. Ayan. So, referring to what has been in the divisibility test, or as far as the content Sir Chancho gave, we will answer exercises 8 and 9 there. So you know that the number 25x 54y is divisible by 72. So find x and y. Wait lang. Okay, again, yung given is 25x 54y divisible by 72. By the way, if you are, as you can see, I will not make it too too organized for the sake of this video because naman nagsasalita naman ako dito, so what I'm gonna write lang is yung mga important operations or important things so that we can finish all the problems that I had here in store. Okay, I mean, I'm gonna try my best uh, to make sure na you can put it into words once you make a solution or a proof in the long test. In the event one of these items indeed come out in the long test. Okay? Anyway. So if this number is divisible by 72, then it is also, diba, divisible by 8 and 9. And I think mas magandang i-explore muna natin ang divisibility by 8 kasi it doesn't consider the x, it only considers the y. Di ba sabi divisibility by 8, divisibility by 8, so this means the last 3 digits are divisible by 8. No matter how many digits the number has, as long as the last 3 digits are divisible by 8, then we can find out the value of y. So 5 for y. Ayan. Suppose yan yung block of number natin. And we can actually write a vinculum. So I'll just write a vinculum so that I can distinguish it na it's digits. It's the y is a digit and it's not 54y or 54 times y. So this is equals to 500 plus 40 plus y, which is divisible by 8. So, mas magandang mag-mod 8 na lang tayo since we're doing modular arithmetic all along. So, mod 8, 40, we cancel that. And the number 480 is the nearest one for 500. Okay. And so, ang pinakamalapit I think is 20 for 500. 20 plus y mod 8. At kung sasabihin natin divisible ang number na to, means, di ba, it's gonna be 0. Ang residue is magiging 0. So the first guess natin would be y equals 4. And yay, we have a first, we have the first digit. Ang kulang na lang is yung divisibility by 9. Divisibility by 9 helps us find x. And again, ano ba ang divisibility by 9? So the sum of digits is divisible by 9. And what do I mean by the sum of digits? Magiging 2 plus 5 plus x plus 5 plus 4. Ay, susulat ko pa ba yung y? Hindi na, since nahanap na natin eh. So, plus 4 na lang. Plus 4. And then, this would be congruent to Ano ba ang sum nito? 2 plus 5 plus 5 plus 4 plus 4. 20 plus x modulo 9. And 20 plus x. X should be a digit, and a number divisible by 9 is suggests that we can set x equals 7. Diba? 20 plus 7 equals 27. 27 divided by 9, 27 is divisible by 9. And so x equals 7. And our x and y again. So our x and y would be 7, 4. And bonus, ang number natin would be 257,544. And you can indeed check that it's divisible by 72. Okay. Sige. So I'll just do a calculator here. Sabi ng calculator ko, kapag daw dinivide mo to by 72, ang sagot ay 3577. Yay! So, exercise 8 is finished. Sige. Exercise 9 naman. Basahin natin again. Suppose you know that 12 to the 10 is equals to 61917 AB4224, where A and B are digits. Use congruences modulo 9 and modulo 11 to determine A and B. Okay. So this is quite fun. Kasi okay. Ang sabi is 12 to the 10 is equals to, copyahin ko lang, 61917 AB 4224. Maniniwala ako kay Lord na magkaparehas lang sila. So, this would be find A and B. Sabi, gamitin daw natin yung congruence modulo 9. So, we know that 12 to the 10 is equals to 3 to the 10, 4 to the 10, and is equals to 9 times 3 to the 8 times 4 to the 10. So it is indeed divisible by 9. What this tells us is kapag minod 9 natin siya, 0 ang lalabas. And this goes the same for the digits. So ang kailangan natin ditong pagtuunan ng pansin is the digits. So 6 plus 1 plus 9 plus 1 plus 7. Yan. To 0 mod 9. And okay. So ano ba ang sum na to? Wait lang ha. So a moment of silence lang. Ika-calculator ko lang talaga. Pati ako hindi ko din ma-compute sa isip. Okay, sabi this is 36, yung mga digits. So, what this means is ang sum ng A and B is divisible by 9. It's either ang sum nila is 9 or 18. 18 meaning both sila ay 9. Next, modulo 11. Actually, if you if you if you just observe, 12 is congruent to 1 mod 11. And so, if you raised both sides to 10, then it should be 1 mod 11 also. What this just tells us is the following. So, gamitin natin yung divisibility rules when gamitin natin yung divisibility rules for 11 for this long string of digits. So, we have 6 minus 1 plus 9 minus 1 plus 7 minus a plus b minus 4 plus 2 minus 2 plus 4 congruent to 12 to the 10, 1 mod 11. And then, okay. So, ano ba ang sum nito? This is 5, 14, 13, 20, A, B, 20 minus 4, 16, 18, 16, 20. So 20 minus A plus B congruent to 1 mod 11. Okay, paano ba to? Ito na yung congruence natin. So, it seems that we have a Chinese remainder theorem here. So, what I mean is, A is congruent to negative B modulo 9. And then, ano ba tawag dito? A minus, so A is also congruent to 19 plus B modulo 11. Ayan. So para bang tinranspose ko lang or nilipat ko lang sa kabila, then na-flip ko lang ulit. Actually, if kung mapapansin mo, I can do it this way eh. So, hindi na pala. Ang gagawin ko, ganito. Ang gagawin ko is, instead of A plus B, so gagawin ko siyang dapat pala A plus B lang pala talaga. A plus B congruent to 0 mod 9. And then we have A minus B congruent to 19 mod 11. Tama ba? A minus B. Yeah. It's correct. And ganito. For us to evade those technical notations, ang gagawin ko dito is, gagawin ko siyang isang expression. So, So then, what I'm gonna do is, I'll make this a plus 10b both sides. So, anong ginawa ko? Nag-plus ako ng 9b tapos 11b respectively. So, which would be 0 and then 19 mod 11. Ah, so you can just think of a plus 10b as a single variable. Okay? So a plus 10b, 0, 19, parang ang game dito is you need to plus something kay 19 para maging divisible siya kay 9. And we can do that if we add 64. Diba? So 64 meaning we have 63. So a plus 10b is congruent to 63 modulo 11. Modulo 99. And okay, parang magic yan Parang hinapiwan ko lang Ganito kasi yung nangyari. Sige na nga. Yan. So, ang ginawa ko is nagdagdag ako ng pitong 9 sa right side. So, magiging 63. And now here, nagdagdag ako ng plus 11b tapos dito 19 plus 44 kasi mod 11 and then modulo 63 modulo 11 yan. So that by a previous theorem you can combine actually this to become 63 mod 99. But then at the same time, kung iisipin mo to as a digit, meron kang BA vinculum BA vinculum 63 mod 99. And ang ibig sabihin lang nito is there is no other way we can set A and B but as 3 and 6. Diba? I hope you see this I hope you see the reasoning. Kasi 10b, so automatically tens digit siya. And then since A siya yung units digit. And we can only solve this by making these positions kasi base 10 ang number system natin So dahil si 10 ay naka-times kay B, ay gagawin natin siyang tens digit. And si A is units digit. And so, there's no other way again. So, A equals 3 and B equals 6. Again. So, ang ginawa natin through this entire example is kinonsider natin siya modulo 9, modulo 11. So, nalaman natin na through modulo 9, ang sum nung A and B should be divisible by 9. Okay, that's one fact. Next, nung dinivide natin siya kay 11, minodulo natin siya kay 11, nalaman natin na 12 raised to 10 is 1 mod 11. And so, by divisibility rule of 11, ginawa natin siya for the right side. And then we come up of 20 minus A plus B congruent to 1 mod 11, which we were able to manipulate as A minus B congruent to 19 mod 11. So para bang, uh, ito, gawin nating star. Yan. So parang yan yung mga main goals natin. Ay, hindi. Star lang pala, star, sorry. Ayan. So once nakuha na natin ito, we can do clever things like adding 10, like adding 11 kay B, and then adding 9 kay B sa modulo 9. And ewan ko ba, kasi kapag ginawa natin to, parang like tinadhana tayong makakuha ng A plus 10B. Na I hope, which is not a coincidence. 'Di ba? Sige. So gagawin ko, ita-times ko sa calculator yung 12, 10 times. So pag nakakuha ko ng 36 dito, edi tama. And indeed, so what I am getting here sa calcu ito. So 12 raised to 10 is 61917 364224. And indeed, it is 36. And yung nakikita nyo ditong A plus 10B, kasi ang goal natin, kung titingnan natin yung example nung kanina, ano 'di ba? 'Di ba ang gusto natin AB? Ba't nakuha natin BA? It just goes to show na you can technically still get the values since we happened to end up in a setup that is perfect, 'di ba? A plus 10B na para express mo siya as a two-digit number. Very perfect. So you don't need to find actually AB. But A plus 10B is enough. Ayan. So I hope na gets niyo yung solution. Sige. If hindi niyo na gets kasi parang I think mahirap talaga tong 9 per se. I-chat niyo lang ako. Okay? So we're done for exercise 9. And let's go to the most awaited part. Awaited part talaga. Wilson's theorem. Okay. So I have picked a number of problems for Wilson's theorem. A number of which has appeared kaninang class. So namili ako ng some problems na lumabas na class. And as of course, hindi ko sinama dito yung exercise 5 ha. Baka sabihin nyo baka isumbong nyo ako. So, ito, for our exercise 1, balik tayo. What are the last two digits of 7 raised to 155? So, ito yung sinolve ni Ali using Euler's theorem. But I do see a reason bakit we can also use I think we can also use Fermat's little theorem here. But the problem is, you don't use it for 100, but you use it for 10. But again, 10 is not prime, di ba? 10 isn't prime, so how would you do this? Okay. Last two digits, so 7 to the 155 mod 100. So kung tatanungin or iisipin natin, 'di ba? If mahirap hanapin yung last two digits, what if we find the last digit? So 7 to the something, sorry, ito na lang. Sige, 7 to the k is congruent to mod 1, mod 10 muna. So let's go back here. So these are two useful theorems to reminisce na we can split something that's modulo mn to modulos m and n. Bakit? Sige. Hapyawan ko lang. So, A modulo B, A congruent to B modulo Mn implies Mn is divisible by A minus B. So, Mn is composite. Okay? Meaning, M and N are numbers that are less than or equal to 1. So, M and N should be at most Mn. Okay? Meaning to say, it's likely na mas maliit yung M and N from Mn itself. Since they are the factors. Which just goes to mean that M divides A minus B and N divides A minus B. Hence, we can express those as modulos M and N. So, paano ba natin gagamitin? So, 10 is equals to 2 times 5. So, 7 to the k, we can express this as 7 to the k mod 2 and then 7 to the k mod 5. Again, ano ba ang sinasabi ng Fermat's little theorem? Ngayon, we have primes already. 2 and 5 are primes. So, modulo 2, this should be 7 to the 1. Diba? P minus 1. 2 minus 1 is 1. And then, 7 to the 5 minus 1 is 4. So, ano ang magandang value na pwede nating iset for k? Siyempre, yung highest, which is 4. I mean, 7 to the k modulo 10 just means na we can set it 7 to the 4 modulo 10. Or we can say the splitting the congruence and using Fermat's little theorem, we can say that 7 to the 4 is congruent to 1 modulo 10. So, okay. Yan na. Tapos na ba tayo? Of course na. Because what we need to find is the last two digits. And we are malayo pa. Anyway, ang ibig sabihin kasi nito, ang units digit ng 7 to the 4 is 1. Okay? As well as, if you raise 7 to the 4 to some exponent, to some multiple, sige, sabihin natin m. 7 to the 4 m is 1 modulo 10. Any power ng 7 na ang exponent is sa multiple of 4 is will give a residue of 1 will 1 divided by 10, or in other words, a units digit of 1. And uh, in the context of modulo 100, since alam natin na ang units digit is 1, then 1 din yung units digit nito. What is the other one? And actually, we can only find it when we evaluate 7 to the 4th itself. Okay, modulo 100. So 7 to the 4 is congruent to 7 squared. 7 squared tuloy. 7 cube. 7 squared, 7. Sige na nga, 7 times 7 times 7 times 7. So 7 times 7 is 49. Okay. And then 49 times 7 is 343. But we are in modulo 100, so 43 times 7. And then 43 times 7 is 301. And 301 is 1 modulo 100. Ibig sabihin, kapag ni-raise mo ang 7 to the 4, ang last 2 digits niya ay 0, 1. But again, hindi ito yung hinahanap natin eh. But it's a good start na alam natin na 7 to the 4 is 1 mod 100. And how would that help us? So, let's consider 7 to the 155. Ngayon, if you can notice, okay, the number next to it, 7 to 156, 7 to 156 is congruent to 1 modulo 100. Kasi nga, 156 is a multiple of 4. Diba nakita niyo naman kanina, diba? 4m. So, ang ibig sabihin, we can try, ito yung sinabi ko kay Jembo na approach. So, we can try to multiply 155 by 7. And that means na, ayan, 155 times 7 to the 1, 7 to the 156, this is 1 modulo 100. Pero anong sinasabi nito? Ano ang ini-imply nito for 7 raised to 155? Ang ibig sabihin lang nito, itong 7 na tinimes natin is the inverse of 7 to the 155. Nagets ba? Inverse yung 7 kay 7 to the 155 kasi kapag pinag-times mo siya, 1 yung sagot. So this is like finding the inverse of 7. So inverses sila ng each other. The inverse of 7 for this context right now is 7 to the 155. And if we can set x, okay, let x, and then let a na lang pala. Let a equals 7 to the 155. So 7a congruent to 1 mod 100. And again, kagaya ng ginawa natin kanina, uh, meron tayong, 'di ba, meron tayong naging product 43 times 7, which is 301. So 1 plus 300, and then 301. Now, we can already divide 301 by 7. So, A congruent to 7 to the 155 is going to be 43 mod 100. Okay, ang significance ng A dito, it's not just something na na display lang. It actually emphasizes its role as an inverse. Okay? Kasi as we get back A as 43 nga, di ba? Maaalala natin na 7 to the 155 pala siya. And so, 7 to the 155 is 43 mod 100, and therefore, the last two digits is 143. Ade, 43. Medyo mahaba, but I think this is the logical way that this problem might go. Okay? So again, ang ginawa natin, from mod 100, we considered modulo 10. Modulo 10, we split it modulo 2 and 5, which we find the smallest k that can satisfy both, or that can make 7 to the k mod 10 1 is 4. And then, we just bumalik lang tayo sa fact na dahil meron nga tayong 7 to the 156 1 mod 100, we can try elucidating the fact that it's the inverse. The 7 is the inverse of 7 to the 155 and vice versa. So I think you're getting the concept naman. Sige, next problem. Ayan. So, again, ginamit natin yung naka-first bullet. I think magagamit din natin yung second bullet. Or, etong purpose ng second bullet is, di ba nung nung nalaman na nating 4 siya, applicable din siya sa mod 10. Like, parang binalik lang natin na applicable pala talaga siya. So, next one. So, prove that n to the 12 minus 1 is divisible by n if the GCD of n and 7 is 1. Or they are relatively prime, kumbaga. Okay. I won't write the formal proof here. So baka tatagalan tayo. But I think you know how to approach this, and this is just Fermat's little theorem. Again, by FLT, okay, pwede namang approach 1. Sige. Ay, wait. central ang FLT. So, ito muna. So, by FLT, we know that 7 to the 6, n to the 6 is congruent to 1 mod 7. If yan. So, ibig sabihin, dahil alam nating n to the 6 is congruent to 1 mod 7, we can just raise both sides by 12 to see that this is also 1 mod 7. And so, by definition of the congruence, we can make this 7 divides n to the 12 minus 1. Done. Yun na yun. If you write it into words na lang, I think sir will understand this. And then, the second one, medyo nabago lang ng konti. So, di ba, given sa atin ng n squared minus 1 eh. So, prove that n to the 12 is divisible by 7. So, we know that n to the 12 minus 1 is equals to the n to the 6 minus 1, n to the 6 plus 1. Difference of two squares. Now, ibig sabihin, this expression, if 7 divides n to the 6 minus 1 n to the 6 plus 1, then one of them must divide 7 by all means. And how can we find that factor? Which among them must divide 7? And yun yung pinapaalala sa atin ng Fermat's Little Theorem na since we know that n to the 6 is congruent to 1 mod 7, then 7 divides n to the 6 minus 1. So any multiple of n to the 6 minus 1 will also be divisible by 7. And what is that exact multiple? Which is n to the 6 minus 1 times n to the 6 plus 1. This, multiplied by this one. Done. Yay! So, yun lang Ang pinagkaiba ng approaches, again, is ni-raise mo yung congruences by 2 and then ginawa mong by definition 7 divides n to the 12 minus 1. Sa second naman, medyo mahaba kasi ginawa mong difference of two squares but you utilized yung definition or maintain mo yung essence nung n to the 6 congruent to 1. Diba? Kasi you can express it, you can state it otherwise as 7 divides n to the 6 minus 1. And dahil gusto natin na yung n to the 6 minus 1 nakikita natin, we can utilize the fact na its multiples will be also divisible by 7. So, preserving its look. Na yung para bang basta makita mo, or as long as n to the 6 minus 1 is present, na hindi ka malulost track. Diba? If that's your preferred way. And okay. Tapos na tayo sa number 3. And ano pa ba? Exercise 4. If P and Q are distinct primes, then P to the Q plus Q to the P is congruent to P plus Q modulo Q. So para bang kailangan nating magsimula by scratch. And hindi ko maalala sino nag-solve nito. Okay. Sino ba to? I think si Seth. Si Seth ang nag-solve nito. Pero pag mali, I mean, it doesn't matter. Ito. So, magsisimula talaga tayo sa scratch. So, kumbaga, oops. By FLP, 'di ba? Napansin mo na yung occurrences ng primes. So by FLP, pwede tayo magsimula on the fact na P to the Q minus 1 is congruent to P modulo Q. And then Q to the P minus 1 is congruent to mali. Sorry. 1 pala. 1. So, modulo P. And we can, sa first congruence, pwede tayong mag-multiply ng P. As well as on modulo on the Q. Now what? So, actually, there's only one trick that you only need to remember. Diba? As we have already witnessed a number of times, we had already added a multiple on the left side or on the right side of the congruence. Now, we will try to add both sides with different multiples. It is possible kasi hindi naman sila nakaka-apekto, di ba? Kasi P to the power of something modulo P is 0. Maka-cancel out lang din naman siya. And that's also the reason why I like modulo. Kasi you can simplify such a stuff to an extent. Diba? So unlike an equation, we can choose to add something on either side of a congruence as long as it's a multiple of m. So, like kagaya na nga ng napakita ko na kanina, ilang beses na, A can be congruent to A plus K times M, modulo M. K is an integer. Integer ha? It can be 0, 1, 2, 3, 4, 5 as well as can be negative. So dito, I can choose to add P to the Q plus Q to the P. Q to the P, this is 0 mod Q. But dito sa right side, I will just add Q. Kasi yun yung gusto nating makuha. And I can do the same. I can add p to the q here. And then p naman sa right side. And okay, everything is the same, the left and the right. Ano na lang ang natitira? Gawin silang iisang congruence. Okay? And that gives us p to the q plus q to the p congruent to p plus q modulo p, their LCM. But then, this is since relatively prime naman sila, ang GCD nila ay 1. So, we can just say that they are mod PQ and we're done. So, I just wrote it the same way. How Seth or some other person wrote this. Okay. Ang in-emphasize ko lang is meron kasing magic trick na mag-a-add ka both sides, mod Q and mod P, to make them the same. Taking note na hindi naman sila nakaka-apekto sa congruence itself. Since it's a multiple, we were adding both sides. Okay. Ano kayang next problem natin? So, next problem is tatlong problems to, actually. Ito, binalikan ko tong problem ni... alam ko tong exercise 8. Kay Linus to. Linus, exercise 8. So, in a nutshell, parehas lang yung ginawa kong approach sa 4. Kinlarify ko lang yung pinaka-step that makes it solvable, provable. So exercise 8, prove that if p is a prime, then p minus 1 factorial is congruent to p minus 1 modulo p minus 1, p times p minus 1 all over 2. We will solve this in a different way, slightly different. And this will use the fact that diba, we have modulo p minus p times p minus 1 over 2. Ang ibig sabihin lang neto is we can actually consider splitting this into p and p minus 1 over 2. Okay. So, medyo hindi siya conventional actually. Hindi conventional na may fraction tayo sa modulo. Kasi we are used to having it in the form P. Ayan. And if we sometimes we fear na baka hindi pala ito magano. So, the thing to remedy that is ganito muna. Walayin muna natin to. We will consider the case, consider p equals 2. Wait. Consider the case when p equals 2. Yan. So, 2 minus 1 factorial, yan. congruent to 2 minus 1 modulo 2 times 1 over 2. And this is exactly 1 congruent to 1 mod 1. Check. Now, consider the primes p where it is now greater than or equal to 3. Or consider the odd primes. Since 2 is the solely even prime actually. Consider all the odd primes na whenever you think about p minus 1 over 2, di ba? We just end up having a factor of at least 1 for it. Yan. P times p minus 1 over 2 can be split into p and p minus 1 over 2. This will be greater than or equal to 3, and this will be greater than or equal to 1. So we are safe of doing this for all the odd primes. Okay. So by Wilson's theorem, p minus 1 factorial is congruent to 1, negative 1 mod p. But this is also the same as saying na pag inad natin yung right side ng p, it's p minus 1 mod p. Okay. So we have 1 out of the 3 steps we need. So this is the second step. It doesn't take a while to realize that p minus 1 is is divisible. Okay, p minus 1 over 2 divides p minus 1. Actually, multiple lang siya. Twice p minus 1 all over 2. Okay? So, ito yung sinabi ko kanina sa slide na to na yan, 0, m, 2m, 3m, modulo m. Na if we write it instead here, so if we start at 0, we start at 0 and then consider the multiples of p minus 1 over 2, we get p minus 1 over 2 congruent to p minus 1 modulo p minus 1 over 2. Yay! Actually, malapit na tayo. Okay? So, again, p minus 1. So, if p minus 1 is a multiple, then it is just the same also as saying na p minus 1 factorial is also its multiple. Okay? Parang ang laki eh. Parang ang laki kung i-evaluatean mo yung p as a prime, parang ang laking number naman nun. But hey, this is still a multiple. Okay? So para bang lipat ko lang p minus 1 factorial p minus 1. And then by a previous theorem, meron na tayong mod p and mod p minus 1 over 2. P minus 1 is congruent to p minus 1 modulo p minus 1 over 2. And so, p minus 1 congruent to p minus 1 modulo p times p minus 1 over 2. Ganito ang ginawa natin. We can assure that p minus 1 over all over 2 is an integer. Kasi p is odd. So, kapag binawasan mo ng 1 yun, even siya. Since even siya, you can divide it by 2 and still be an integer. But, also, take note na since p, diba, we have p greater than or equal to p minus 1. No. It's less than. It's greater than p minus 1 over 2, actually. And what this just means is, since p is prime nga, it's divisible, it is relatively prime to the numbers less than it. To those positive integers less than itself. Okay? And that includes p minus 1 over 2, which you can locate somewhere, like in the half. In the half. Yeah. So p is relatively prime to p minus 1 over 2 due to the definition that we set to p. And so, ang GCD niya will always be 1. And so, that's also the reason we can multiply both the numbers. Gets? Okay. Itong 9, medyo ewan. Itong 9 naman, show that for all integers a and b with GCD of p and a and p of b both 1 for prime p, prove that a plus b to the p, a quantity a plus b to the p, is congruent to a to the p plus b to the p mod p. This is quite straightforward as I solved this a while. Diba? Prime p, so p is still an integer, so binomial theorem still works, still applies. Diba, sabi ng binomial theorem, this would be k equals 0 to p ng p to the k, a to the p to the k, b to the k mod p. So, ang target natin is to see that it's congruent to a to the p plus b to the p. And how can we do that? So, pwede tayong maglabas ng terms sa summation na to, which is a to the p. But then, ano yung value ni k na yon? What value of k corresponds to a to the p? And that would be k equals 0. So, plus summation. Okay? Summation pa din. So, wala na yung k equals 0. We have k equals 1 na. Plus b to the p. So, we have b to the p mod p. B to the p. So, tinanggal natin yung b. Yung k equals p dito. So, instead na from 1 to p, magiging k runs from 1 to p minus 1 na lang yung summation. Okay? Sige, para mas madali, try nating i-grupo. So, a to the p plus b to the p plus the summation, okay, p to the k, p choose k pala, rather. So, ibig sabihin would be p factorial over k factorial p minus k factorial. And then also, ang magandang gawin dito kasi is, ang gusto ko is ma-factor out ko tong p from the p minus k. So, para bang ang gagawin ko is magiging joke. I know, so kung alam ko nag-discrete math tayong lahat. So, p minus 1, k minus 1. Wait, nag-discrete math ba? I think we can do this. B to the k mod p. So that, ang point ko dito is para ma-realize natin we can actually take out the p so that ang binomial coefficients would adjust. But sa process na tinanggal natin yung p, we still end up having parang ganito. P choose k is equals to p times p minus 1 choose k minus 1. So, merong combinatorial proof yun. Which, for the sake of brevity, is wag na. So, bale, ito, a to the p plus b to the p, this summation, k minus 1. Ayan. And indeed, ang point lang nito is ilabas mo yung a to the p plus b to the p and i-manipulate mo yung natitirang expression. Once you find out na pwede mong ilabas yung p, like for this example, but this is not just one of the ways you can take out the p, ha. Pwede din naman yung ginawa ko kanina na ito. Yung finactorial ko siya, p factorial divided by k factorial p minus k factorial. So, equals to, parang same process lang din nang gagawin natin siyang binomial coefficients. So, k factorial p minus k factorial. Yan. And then, actually, this is a binomial coefficient pa din eh. Yung p minus 1 tas p minus k. Kasi, or kailangan natin ng kailangan natin gawin ganito. minus k minus k minus 1. Ayan. No, 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 no. Mali, mali, mali. Kailangan natin tong ano ng minus 1. Ayan. But anyway, nakakatamad. Mas kabisado ko yung ganitong, yung version ng binomial coefficients na ganito. But, sige. We're on the same page na sana hindi to lumabas sa exam. Please. If ever hindi niyo man kaya to, hindi niyo man to kayang i-explain, I would understand. Kasi di ko din kaya. Maybe we'll find a way. Sige. Exercise 10. And surprisingly, hindi pa tayo natatapos sa Wilson's and FLT. Ito na yung last talaga. Last ng Wilson's theorem and FLT. So show that if P is a prime of the form 4n plus 1, then 1 times 2 to the 2n squared plus 1 is congruent to 0 mod P. Show daw. Okay. Ang idea dito is, ito. Sulat natin. P is of the form 4n plus 1. Ang gagawin natin dito is itong diba, from 1 to 2n, we can just express this instead as 2n factorial squared plus 1. So this is congruent to 2n factorial plus 1. And then ano ba ang mod niya? Mod and then we can actually revert back yung iba plus 1 ngayon. So another magic trick we can do is not really a magic trick, but siguro an intended solution for here is to add both sides by 4n plus 1. Add both sides by P, kumbaga. Or wait, parang mali. Sandali. Again, basahin ko lang yung problem. Up to 2n to hindi siya like times 2n lang, 2n squared. So actually, may ginawa ako dito. Mga rough sketches lang din sorry. Ayan. Ito yung ginawa ko for 10 then I get it. So again. Tingnan natin. Pero wait, it's not. Parang mali yung ginawa ko dito. Is a prime of the form 4n plus 1 kasi. So ang ginawa ko nun, pinlas ko siya ng 2n. But it's not the right thing to do. Kasi nga it's in the form 4n plus 1. So dapat 6n yun. So para bang ang nangyari siguro is or I am doing it the wrong approach all along. Ganito. So let's do an impromptu. So that path doesn't work. So what might work is 2n factorial is congruent to negative 1 modulo p. So as you can see, I am about to backtrack this problem. And if it's negative 1 modulo p, then this is also equivalent to p minus 1. But then n is in the form 4n plus 1, so 4n factorial. Diba? 4n, so that it becomes Sure, actually. Paano kaya to? Oh, I have an idea. Okay, so ang gawin natin, tama lang pala. So 2n factorial and then 1 times 2 times, hindi, sige ganito na lang, times 2 times up to 2n plus 1. Ayan. Ito yung original natin ha. So we can subtract everything by p. We can do that. Kasi ito magiging 2n factorial times 1 minus 4n plus 1. So that's negative 4n times negative 4n plus 1 until we get to ano ba to? Negative 2n plus 1. Minus 1 ata. Ay, minus 1 ba? Yes. Plus 1. So, ang ginawa natin kasi dito is, ayan, mod p pa din siya. But now, yung bilang ng mga binaliktad natin is 2n. So if we take out the negative sign, ang goal ko dito is maging 4n factorial to. So negative 1 to the 2n of 2n factorial times 4n times 4n minus 1 up to 2n plus 1 plus 1. Which is going to be sa dito naman sa negative 1 natin 1, so disregard na lang natin yan, 2n factorial, and then we meet numbers 2 from 2n plus 1 to 4n, and then so we have 4n factorial plus 1 mod p. But mod p is in the form 4n plus 1. So we can try substituting p as 4n plus 1. And so, yung magiging factorial by Wilson's theorem, okay, by Wilson's, four n factorial is congruent to negative 1 mod 4n plus 1, which means na we have negative 1 plus 1 congruent to 0 modulo p. I think mas magandang gawing siya, we just remain it as p as is. Yan, para mas evident yung calculations. Yan, it leads to 0 mod p. And actually, ngayon pa lang tayo natapos sa Wilson's theorem na to. Ano ba yan? Ang tagal. Yun ba yung ginawa natin? We already did a total of, I think, 10 exercises. Okay. So, these are the last 4 exercises that we will do. Kasi parang nakukuntian ako sa Euler's theorem. And it's such a good theorem to use. So, the number 3, for this one, the number 3,750 satisfies the phi of 3,750 equals 1,000. So we need a number A that satisfies the 3 conditions. It's 7 to the 3003 mod 3750. Well, this is pretty straightforward yung unang condition. Sige. So 1 says that A is congruent to 7 to 3 7 is congruent to 3003. But by Euler's theorem, since we are in modulo 3750, This is just the same as 7 to the 1000 cube. 7 cube. Modulo 3750. And this is congruent to 7 cube. And this is congruent to 343. Ayan. So one basic requirement for you guys and for me as well is to memorize the prime powers. Prime powers of 2, 3, 5, 7, 11, 13. As long as we know those, mabilis lang yung calculations natin. Again, 343 mod 3750. And then, but sa second condition natin ay A should be between 1 and 5,000 inclusive. So we already figured out that A is equals to 343. But we can also say na since this is mod 3750, put it in 343 plus 3750. And what would be that value? It should be 4093. Yay. So A, ang sabi dito, A is not divisible by 75. So are there any of the values that is divisible by 75? And you can just do straight division for that. And yes, wala namang divisible sa kanila. So iyon na yung mga values mismo. So A equals 343 and 4093. Exercise 2 is just straightforward application ng Euler's theorem per se. So meron pa tayong last 3 problems here. And I don't know kung gaano to katagal. So, ito. So, show that if A is an integer such that A is not divisible by 3 or such that A is not divisible by 9, then A to the 7 is congruent to A mod 63. Parang may pinaghalong Eulers and Fermat's. Sige. I will let it stay still for 10 seconds. Okay. So naghanap talaga ako ng bonus items for number 1. Okay. Actually, this is more like a Fermat's little theorem. Yung parang sa ginawa natin kanina na 7 to the 155, but then binago natin yung modulus. We had 63. So, sige. Euler's theorem says na if phi of 63 is equals to 6 times 6 equals 36. Okay. Diba phi of 9, phi of 9, phi of 7. So, 66, 36. Then, A of 36 is congruent to 1 mod 63. Ang ini-imply dito is, yan, di ba? Sabi nga kanina, yung exponent is not necessarily small, okay? Not necessarily the smallest. Euler's theorem doesn't give the smallest exponent that makes A become 1 mod 63. There can be smaller, and it depends on the base itself. Okay? And depending on the base, kasi iba-iba yung nature ng numbers eh. So, we need to try them out per base. But as far as 63 is concerned, it's a special number. We can make the base even smaller. Okay? And what I mean by this is, instead of solving this by Euler's, in which you can see a to the 36, a to the 7. So parang this suggests na kapag dinivide mo siya by a to the 6. Ang layo, di ba? So medyo meaningless yung spot natin. So, okay. So let's assume that we still don't know about a to the 6 equals 1. So let's think of something that's 1 mod 9, and then that's also 1 mod 7. By Fermat's little theorem, this would give us a to the 6 congruent to 1 modulo 7. Kasi 7 is prime eh. Ito naman, 9. This is not prime. And then, this is Euler's. So by Euler's, you have a to the 6 congruent to 1 modulo 9. 6 is phi of 9. Okay? And wow! Magkaparehas sila ng exponent, a to the 6, a to the 6. Ang ibig sabihin nito, pwede nating i-combine using the previous theorem, di ba? Since parehas ng left and right side ng ang congruence, it just goes to show na a to 6 is 1 modulo the LCD of 7 and 9, which is a to 6 congruent to 1 mod 63. And so, as we multiply an a that's not divisible by 3 nor divisible by 7, we get a to the 7 congruent to a mod 63. And done. Yay! So we have last two problems actually. Last two problems here. Ito na yung huli. Second to the last. Show that if a sub 1, a sub 2 up to a sub phi of m is a reduced residue system modulo m, where m is a positive integer with m not equal to 2, then the sum of those reduced residue systems is 0 mod m. So naglagay na talaga ako ng hint para malaman niyo yung gagawin. And actually, merong formula to. But for the sake of this problem, we will just uh, we will just focus on how to prove this. So a sub 1, a sub 2, a sub m. So for this bonus number 2, without loss of generality, so let's say na, wait, can I say this? Parang hindi na ata pwede. Or not necessarily. Ganito. So, gagamitin natin yung hint kanina na if A, tama ba ang ano natin? If A, M, if the GCD of A and M is 1, then the GCD of A is M is 1. Actually, ito yung mas appropriate kaysa sa A. Kasi it's not modulo A eh. It's modulo M. I mean, I am signifying this one. Ito. So, I think it should be M. Okay. So, ito muna ang claim natin. Claim. Parang, ayan. So, if A comma M is 1, then M minus A comma M is 1 also. So, ang proof, so let's assume na di pa natin alam yung GCD. So, like the GCD of M minus A and M is D. It means D divides M minus A and then D divides M. But then since D divides M, di ba? We can say na D divides M minus A minus M. Kasi nga, D divides M. So, pwede nating i-minus yung M sa M minus A. Parang pinagsama-sama ganun. Which means D divides negative A. And negative A is a multiple of A. Which just means it's D divides A. But but then sa first statement natin, 1 divides A and 1 divides M. D is the GCD. And there's no other way, okay? So there's no other way but telling that D divides the GCD. Okay? D divides the GCD of A and M, which is equals to D divides 1. And so, D equals 1. Okay. Nice. So, ano ang ibig sabihin nito? M minus A, the GCD of M minus A and M is 1. So, ano ang kailangan nating ma-realize? So, sa reduced, okay, balik natin tong reduced system natin. So, A sub 1, A sub 2, A sub 3, to A sub P of M. Ang ibig sabihin lamang nito is, ang importante na ba't tayo nag-claim is, kailangan natin ng malaman na magka-pair itong A tapos M minus A. Ayan. Makakabuo tayo ng mga pairs of numbers na that sum to M Okay, and uh, they are mahahanap natin sila somewhere in this reduced residue system. Itong A saka M minus A, wherein kung itong A, uh, if this A is in the reduced residue system, so is M minus A. Kasi the GCD of AMM is 1. And the GCD of M minus A and M is also 1 too. Kailangan. Diba? It must be. And so, ang gagawin natin is we will be forced to say na phi of M will always be even. Okay? Always be even in the sense na we can partition this we can partition the reduced residue system, diba? Partition this into A sub 1, kunyari A sub 1, A sub 2, A sub 3, A sub 4, A sub phi minus M minus 1, A sub phi of M. Yan. So we can actually do this. Pero parang abstract niya tingnan eh. So, let's try muna kaya tingnan natin yung example. Let's say meron tayong reduced residue system modulo 9. Sige, pagkatapos nito, babalik tayo sa abstract proof natin. So, 1, 2, 4, 5, 7, 8. Pag pinag-add mo tong elements na ito, so 1 plus 2 plus 4 plus 5 plus 7 plus 8. So, magiging sum equals 27. Okay. 27, 27, so 9 divides 27. Yes. Works. How about reduced residue system modulo 11? Ay, wag. 12 na lang. So, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Ayan, 4. So, ang sum nila is 22. Ay, mali. 24. And then, 12 divides 24. Diba? So, ang idea dito is, balik tayo dito sa balik tayo sa ideas natin. Prove. So, na-prove natin itong claim. Ibig sabihin, we can divide these phi of M integers into two pairs. Like, So this set actually can be, kung titingnan natin tong mga naging dalawang sets natin, we can divide the sets around here and around here, na ito, di ba, phi of 12 is 4, phi of 9 is 6. So kalahati ng phi of 9 would be less than, ayan, would be the A counterparts. And then ito, yung magiging M minus A na counterpart, as well as these. Ayan. I think nagigets nyo naman na. Ito. So, again, so this set can be grouped, divided into two disjoint subsets. And how would we divide this formally? So, yung counterparts would be A. So, suppose A counterpart sila, may phi of M over 2 na counterparts is A, and then phi of M over 2 na ang counterparts is M minus A. Yun yung sinasabi kong subset. And kapag sinam natin yun, di ba, A plus quantity, parang ganito, yung sum na tinutukoy natin would be phi of M over 2 times A plus phi of M all over 2 times M minus A equals M times phi of M, M times phi of M over 2 modulo M, which is 0. Okay? I am thinking kasi of something na might be pwede natin gawin, na since alam nga natin na kung merong A sa reduced residue system, meron ding M minus A, I am thinking of a scenario na ipag-add natin yung same set, na which makukuha muna natin yung formula itself na para bang kumbaga ito, alternative perspective. Sorry kung wala kayong nagets ha. So yan. So plus A plus A plus A. So ito yung A counterparts. Okay. Gawin na natin siyang inclusive for all. Okay. Na kung merong A counterparts yung isang element, meron siyang M minus A counterpart. And we are just talking about the reduced residue system. Na somewhere somewhere on this same set natin, same system, may mahahanap tayong M minus A counterpart niya. And I would denote this just by the question marks. But this is just in parang some ordering lang ng set na alam nyo, kasi we can just tell we can just tell lang na this would be a phi of M which is equals to kaya nga lahat ng A tapos M minus A counterparts pag pinag-add mo yun magiging M. But then nag-add tayo ng phi of M terms. So phi times M. And so this sum would be M phi of M over 2 yan. And so when you modulo M this term on the right, it gives you 0. Yeah, that works. Yeah. Parang ito ata yung mas madaling solution kaysa sa dito. Kasi dito, ipa-partition mo eh. Tapos, you'll be subject to the yung like the formal way of partitioning it. So hindi ka totally sure na you have partitioned it based on the conditions you have set in the reduced residue system. Yeah. So to recap, ito yung ginawa natin. Ang pinaka cornerstone claim natin is yung GCD ng A and M tapos yung GCD ng M minus A and M para makahanap ng partner yung isang residue na magsasum siya sa M. Kasi nga ang goal natin is 0 yung modulo M. And pinakitaan ko naman kayo na example, ayan, na pwede nating hatiin yung 1, 2, 4 sa 5, 7, 8. Diba? Pansinin nyo, 4 plus 5, 9. 2 plus 7, 9. 1 plus 8, 9. Sum 27. Ganon din sa modulo 12, reduced residue system. 5 plus 7, 1 plus 11. And 12 divides 24. Ayan. And okay. So, that's horrifying as a proof. Sana hindi to lumabas, please. And for the last question, I think Euler's theorem will be useful now here. So what is the remainder when 1 to the 2018 plus 2 to the 2018 up to 2017 is divided by 2018? This is kind of straightforward. So bonus number 3. Ito na talaga yung pinaka-last natin. And I apologize kung masyadong mahaba to. I just really wanted to compact everything in a single video so that we can maximize time. Yan. Tama. Automatically, we can use Euler's theorem. So, if we let S be the sum, then wag na tayo mag-let S. Ito na lang. Sulat na lang talaga natin. So this is modulo uh, modulo 2. So modulo 2 and then modulo 1009. So 1009 is prime, alam ko. Yan. Bale, yeah, by Euler's theorem, lahat ng terms would be congruent to 1 modulo 1009. Wait. Diba? Euler's theorem, Fermat's little theorem says na Fermat's little theorem says na parang mas mahirap to kapag Euler's theorem eh. Kasi 2016, 2018, you are not sure, hindi ka pa masyadong sure kung tama ba yung may masasama tayong mga numbers na divisible by 2. So, mas safer na split natin yung modulo 2018 by 2 and 1009. So, FLT says that for some term, A is congruent to 1 mod 2 and A to the 1008 is congruent to 1 modulo 1009. Okay. So 1 modulo 1009, this only applies to the A na hindi na relatively prime kay 1009. And okay, so this means na lahat ng mga sums, so sige na nga, let S na lang natin to. So si S would be congruent to, ilan ba yung odd numbers natin sa, we can just look at the bases. So ang highest number natin is 2017, so it's like 1008. Yeah, 1008. Kasi 2 times 1 minus 1. Ay, hindi. 1009 pala. 1009 mod 2. Okay. 1009 odd numbers. And then, S would be congruent to ilan ba ang relatively prime. So, ibabawas natin yung ibabawas natin yung 1009 itself. Okay, yung 1009 raised to 2018 kasi wala, zero yan. 2017 minus 1, 2016. Modulo 1009. And then this 1009 would be simply this would be S again, this is 1 mod 2, and then this would be 1007 modulo 1009. Yeah. And so yes, it's 1007. So the remainder is 1007. 2018 pala. Yeah. Tingnan ko lang ulit So again, let S be the sum. Tapos split mod 2 and mod 1009. So meron tayong 1009 odd numbers as 1, 3, 5, 7 hanggang 2017. So 1009. And the next, by Fermat's little theorem, A to the 1008 is 1 mod 1009. So A to the 2016 is mod 1009. Oh, wait a minute. Parang may nakalimutan ako. Whoa, whoa. Sorry. Hindi pa nakalimutan ko na square pala yun. Sorry. Kaya para akong magsa-second guess sa sagot ko. Parang hindi to tama. Wait lang ha, wait. So 1 to the 2018. Kasi ito, A to the 2016 congruent to 1 mod uh, 1 mod 1009. So 1 squared plus 2 squared up to 2017 squared. But then kailangan nating i-minus yung 1009. Kasi wala na yun. Hindi kasama sa congruence yun. Hindi siya satisfied ng Fermat. Yan. So we will leave that as is. Yung ganyang expression. And mind you can actually compute it. So 2017, 2018, 4035 divided by 6 minus 1009 squared. And ano ba ang value nun? Sige. Gagamit ako ng calculator for that. Oh, wait lang. I don't need a calculator. So, this is going to be 2017 1009 times 4035 is divisible by 3. So, ano ba ang number na yan? Well, this is 0 mod 2009 actually. Ayun. 0 mod 1009. And so, if S is 1009 mod 2, instead of 0, we can say we can add 1009 to the right side. And yeah, S would be via previous theorem, nakailang applications na tayo na ito. So it's really useful. S is 1009 modulo 2018. And this is the remainder. And I think it is the remainder, actually. So yeah. Kung nakinig ka from first to last, thank you for your listening. Actually, ang daming naging spoilers nitong video na to. And sana hindi maging boring ito once this video is going to be watched by you guys. And I really recommend, I will recommend na lang siguro on the Messenger GC na dapat you will just view sections which you think is good or beneficial. Ayun lang. So, adios guys. Good luck sa LT. Ayan lang.